Hello everyone. Last time we covered mole to mole conversion, so today I'm gonna go to the next part, that is mole to mass or mass to mole conversion. Same steps, three column, the easy way to do the mole conversion calculations. So for that, first of all, we should know about the balanced chemical reaction, which you can see I already have reaction written for the calculations. So in this reaction, we are reacting 4 moles of ammonia with the 5 moles of oxygen. Moles means coefficient in front of the formula. And we form 6 moles of water with the 4 moles of nitric oxide. Here we go. Let's go to the question. How many grams of water are produced if 2.2 moles of ammonia are combined with excess of oxygen? So it's pretty clear from the question that you need to convert moles of ammonia into grams of water. So let's start with the question. So three column. In the first column, what do you know? Third column, what do you need to find? What do you need to find? In the middle column, conversion factor. So now in this part, mole to mass, mass to mole conversion, so your conversion factor could be 1 or 2 types conversion factor from balanced equation. So let's check. So what do you know? I know 2.2 moles of ammonia. And what do you need to find? I want to find grams of water. So it means you will start with the ammonia, you will end with the water. So how will we get water on stage? So for that, we need to use the conversion factor, mole ratio. So it means first we need to remove this ammonia. So let's go to the chemical reaction, balanced reaction. How many moles we actually use for ammonia in the balance equation? You can see it's 4 mole. So we will write 4 moles of ammonia as the denominator because we want to cancel the ammonia. And how many moles of water we have produced? We have produced 6. So 6 moles of water will be at the top. Reason we need answer in the form of water. So moles ammonia out. So we have now water, but that is in terms of moles. So we need answer in grams. So what to do? So here we will use our mole concepts. You can see in this middle column, I have used 2 conversion factors. One is a molar ratio. This one is your molar ratio. And second one I will use the second concept because I need to convert moles water into grams. So standard information. 1 mole of H2O is equal to molar mass. That is 18 grams of water. Here we go. Moles out, grams in. So here we go. We'll use the Desmos calculator. I will show you the Desmos calculator. So, or we can use the simple calculator. We don't have. So 2.2 multiply 6 and multiply 18 divided by 4. But I will say encourage your kids to use the Desmos because you have to use some mole concept. So we have our exponential term. So some kids they are confused by using these normal calculator. So our answer is 59.4. Here we go. So this is our first question. So 2.2 moles of ammonia and we have 59.4 grams of water produced. So here we go. This is our first one. Let's go to the next part, which is already ready here. So I'm gonna show you here 2 parts. one chemical reaction. You can see I've already circled the moles. 1 mole of potassium phosphate combines with 1 moles of aluminum nitrate, form 3 moles of potassium nitrate, forms 1 mole of aluminum phosphate. If there is no number, it means it's a 1. So be very careful. Let's go to the first question. What is the mass of potassium nitrate that is produced when 2.04 moles of potassium phosphate react? So same thing, same concept. Here we go, 3 columns. I will say the middle column, keep it a little bigger. So what do you know? What do you know here? Here we go. What do you know? Third column, what do you need to find? Why I'm writing first and third column before the middle column, so that we know which conversion factor will be in the middle column. So that will be decided by first and third column. What do you need to find? What do you need to find? And in the middle column, conversion factor. Conversion factor could be 1, could be 2, or sometime could be 3. That will be the next part, mass to mass conversion. So here we go. So what do you know? I know 2.04 moles of potassium phosphate. Moles of potassium phosphate. I will just write the formula. Potassium phosphate. What do you want to find? I need to find mass of potassium nitrate. So means grams. Mass means grams. Potassium nitrate. Here we go. Potassium nitrate. I'm sorry. Potassium nitrate. So same thing. How will we get potassium nitrate on stage? With the help of molar ratio from the balance equation. So how many moles of potassium phosphate we have used? We have 1 mole. We will write 1 mole of potassium phosphate as a denominator because we want to cancel it. Whatever you want to cancel it, that should be as a denominator. Whatever you need your answer, that should be as a numerator, means at the top. How many moles of potassium nitrate we have formed? We formed 3 moles. 3 moles of potassium nitrate. Here we go. Moles out of potassium phosphate. We have moles of potassium nitrate, but we need answer in grams. So you can see have molar mass of a few compounds already here ready. So we can use molar mass of potassium nitrate. So I need to cancel the moles. I will write 1 mole at the bottom. 1 mole of potassium nitrate in terms of grams is equal to 101 grams. Moles nitrate out and grams of potassium nitrate in. So let's check the answer. 2.04 multiply with the 3 multiply with the 101, that is equal to, you can see it's a big number, 618. 618.12 grams. Here we go. So we're done with the first part. Let's check your second question. Here we go. Oops, columns are till 2. I erased accidentally. Okay, here we go. It's okay. Second question. Second question, now we're gonna start with the grams. 5.80 gram of aluminum phosphate are formed. How many moles of aluminum nitrate reacted? So this time I will start with the potassium phosphate. So potassium phosphate is already here, you can see. Same, what do you know? I know 5.80. This time it's a gram aluminum phosphate. Gram aluminum phosphate. And what do you want to find? I need to find moles of aluminum nitrate, aluminum nitrate. How will we get aluminum nitrate on stage? With the help of molar ratio. It means first I need to change these grams into moles. If I want to use the molar ratio, you cannot use molar ratio here. Keep in mind, it's very, very important. So how will we convert grams into moles? So we will, now this time I need answer in grams. So I will write mole at the top. 1 mole of aluminum phosphate is equal to, you can see, 122 grams of aluminum phosphate. Grams out, moles in. Now we can convert this mole aluminum phosphate to moles aluminum nitrate. So you don't need answer in aluminum phosphate. So I want to see how many aluminum phosphate we have used in the balance equation. You can see it's 1 mole. Write down 1 mole aluminum phosphate as the denominator. And how many moles of aluminum nitrate we have used? Again, it's 1 mole. Luckily, 1 mole of aluminum nitrate at the top. You can see it's not difficult. It's just how you use the conversion factor. So it's the whole game of conversion factor. Aluminum phosphate out. So keep in mind when you're using conversion factor or doing the mole conversion calculations, make sure you're writing these units. If you are not using units, so there are chances that you will do mistakes or you will use the wrong conversion factor. So now I'm left with moles of aluminum nitrate. This is what my question is: how many moles of aluminum nitrate reacted? So let's check the answer. 5.80 times 111. We don't have to write 1. Anything multiplied with the 1 is the same number. Divided by 122. That is equal to 0.0475. So 0.0475. Answer is 0.0475 moles. So this was all about second part, mole to mass or mass to mole conversion. So next time I will show you mass to mass conversion. Same concept. So we should know how to find the molar ratio. Molar ratio means the number in front of the formula. Balanced chemical reaction, keep in mind. This number is also known as coefficient. So coefficient means moles. So 3 column, what do you know? Conversion factor and what you need to find. If you will first write column 1 and column 3, then you can pick which conversion factor will go in the middle. Then it's pretty easy. So I hope it helped you with the second part of mole conversion calculation. Next time I will come with the mass to mass conversion. Thank you. Bye bye.